For years, Elon Musk has positioned Tesla Optimus as a breakthrough in American robotics. A humanoid robot built to reshape factories, households, and eventually the global labor market. But now a new question is surfacing. What if a significant portion of Tesla Gen 3 components are coming from China? Motors, actuators, precision gear systems, battery materials. If Optimus relies heavily on Chinese suppliers, what does that mean for cost? And more importantly, what does it mean for pricing? Because here is the reality. If Tesla sources critical robotics components from China, Optimus could become dramatically cheaper to manufacture, but could also face geopolitical risk. Today we're going to break down whether Tesla Gen 3 is quietly leveraging massive Chinese component supply, how that impacts cost structure, and whether this could finally push Optimus closer to Elon Musk's long-promised affordable price range. If you want realistic, no-hype analysis about Tesla technology, supply chains, and long-term strategy, make sure you subscribe to the channel right now. We focus on facts, industrial trends, and economic reality, because this is not just about where a robot is built. It is about how global supply chains shape the future of robotics. Let's begin. Why China matters in robotics manufacturing. Before jumping to conclusions, we need to understand something clearly. China is not just a low-cost manufacturing hub anymore. China is the global leader in several critical robotic supply chains. This includes precision actuators, harmonic drive gear systems, brushless electric motors, rare earth magnet production, battery cell materials, high-volume electronics assembly. If Tesla wants to produce millions of Optimus robots in the future, sourcing some components from China would not be unusual. In fact, it would be logical. Let's break this down. 1. Actuators and harmonic drives. The most expensive mechanical parts inside a humanoid robot are its actuators and gear reduction systems. Each Optimus arm reportedly contains more than 20 actuators. Multiply that by 2 arms and 2 legs, plus torso joints, and the component count rises quickly. Chinese suppliers currently dominate mid-range harmonic drive production and precision servo systems at scale. Japanese companies still lead in ultra-premium robotics components, but China has dramatically improved quality while reducing cost. If Tesla sourced even partial actuator systems from Chinese manufacturers, production cost per robot could drop significantly. And that matters, because cost per unit determines whether Optimus stays at $200,000 or eventually approaches the $20,000 to $30,000 long-term goal Elon Musk once mentioned. 2. Rare earth and magnet supply. Electric motors require rare earth magnets. China controls a large percentage of global rare earth processing capacity. Even if Tesla assembles Optimus in the United States, many magnet materials could originate from Chinese supply chains. This is already true for electric vehicles. So the real question is not whether China is involved. The real question is how dependent Tesla becomes. 3. Electronics and AI hardware. High-density circuit boards, motor controllers, sensor modules, and camera systems are often manufactured in Asia due to existing infrastructure. Scaling robotics production without leveraging established electronic supply networks would dramatically increase cost. And cost is the main barrier preventing Optimus from becoming mainstream. Now here is the tension. Lower cost manufacturing increases accessibility, but heavy foreign dependency introduces geopolitical risk. Before we move deeper into pricing implications, ask yourself this. If Optimus becomes affordable because of Chinese component sourcing, does that matter to you? Or does supply chain independence matter more? And if you appreciate balanced analysis instead of emotional reactions, make sure you are subscribed. This channel focuses on strategic thinking, not headline panic. Now, let us analyze the real financial impact. How much cheaper could Optimus actually become? Now, let us talk about numbers, because supply chain debates only matter if they change the final price. Elon Musk has previously suggested that long-term, Optimus could cost between $20,000 and $30,000 once production reaches scale. Right now, early units are expected to cost far more due to low-volume manufacturing and custom components. So how does sourcing components from China change that equation? Let's break it down realistically. 1. Actuator cost compression. High-precision actuators can cost hundreds of dollars each in low-volume production. If Optimus contains approximately 40 to 50 actuators across its body, even a $200 difference per actuator changes total cost dramatically. Imagine saving $200 per actuator across 50 actuators. That alone could reduce cost by $10,000 per unit. At mass scale, Chinese suppliers can reduce actuator pricing significantly due to vertical integration, large-scale robotics manufacturing, established supply chains, lower labor cost. That is not speculation. It is manufacturing economics. 2. Electronics and assembly savings. Printed circuit boards, sensor modules, wiring harnesses, and motor controllers are far cheaper when produced at high volume in Asia. Even a 10 to 15% cost reduction across the electronic bill of materials can move the final product price downward by several $1,000s. And robotics is extremely component-heavy. Every small reduction compounds. 3. Battery and material sourcing. If Optimus uses lithium-based battery systems similar to Tesla vehicles, Chinese battery supply chains already dominate global production capacity. Leveraging that infrastructure instead of building a fully domestic robotics battery supply chain reduces capital expenditure. Lower capital expenditure means lower amortized cost per robot. This is how scale lowers price. But here is the important distinction. Cheaper components do not automatically mean cheap robots. Integration still happens in the United States. AI chips are expensive. Research and development costs must be recovered. Factory tooling and robotics assembly lines require billions in investment. So even with Chinese components, early Optimus units may still remain expensive. However, long-term cost targets become more realistic if supply chains are optimized globally. Now here is the strategic twist. Tesla has always balanced global sourcing with domestic assembly. They manufacture vehicles in Shanghai for Asian markets. They produce in Texas and Berlin for Western markets. Optimus could follow a similar hybrid model. Before we go further, if you want continued deep dives into Tesla's supply chains and robotics economics, make sure you subscribe. Understanding cost structure is the key to predicting future pricing. Now we need to address the real concern. What happens if geopolitical tension disrupts these supply chains? The geopolitical risk no one talks about. Now we reach the uncomfortable part of this discussion. Lower manufacturing cost is attractive, but global supply chains come with strategic risk. If Tesla sources a significant portion of Optimus components from China, 3 major vulnerabilities appear. 1. Trade tension and tariffs. The United States and China have experienced multiple rounds of trade friction over the past decade. Tariffs can change quickly. Export restrictions can appear without warning. If critical robotics components are suddenly restricted or taxed heavily, production costs could spike overnight. And robotics margins are already tight during early scaling. A 10 to 15% tariff increase could erase cost advantages instantly. That is the first risk. 2. Supply chain disruption. Global events can interrupt manufacturing flow. Pandemics, shipping bottlenecks, geopolitical conflict. Tesla already experienced supply chain strain during global chip shortages. If Optimus relies heavily on one region for motors, actuators, or electronics, production continuity becomes fragile. And robotics requires precision timing. Missing even one specialized actuator halts an entire assembly line. That is the second risk. 3. Strategic technology sensitivity. Humanoid robotics is not just a consumer product category. It has implications for industrial automation, military logistics, advanced manufacturing, Artificial intelligence integration. Governments may eventually classify advanced robotics components as sensitive technology. If that happens, export controls could tighten further. That could force Tesla to localize more production domestically. Localization increases cost in the short term, but it reduces dependency long term. Now here is the strategic balance. Tesla historically diversifies supply chains. They do not rely on one country exclusively. Even in electric vehicles, Tesla sources from multiple regions to reduce risk exposure. Optimus will likely follow a similar model. Partial Chinese component sourcing, partial domestic assembly, gradual vertical integration over time. Because Elon Musk understands something critical. Long-term dominance requires both cost efficiency and supply security. Before we close this topic, ask yourself this. Would you prefer a cheaper Optimus built through global supply chains, or a more expensive one built entirely domestically for strategic independence? There is no simple answer, and that is why this debate matters. So, will Optimus actually be cheaper? Now let us answer the core question clearly. If Tesla uses significant Chinese components in Optimus Gen 3, will the robot become cheaper? The honest answer is yes, but not immediately. Here's why. Short-term reality. In the early production phase, Optimus will remain expensive, even if Tesla sources lower-cost actuators, motors, and electronics from China. Research and development costs are still high. AI chips remain expensive. Low production volume keeps unit cost elevated. Factory tooling and robotics assembly require heavy capital investment. Early units could still cost well above $100,000, especially if production volume is limited. So do not expect an overnight $20,000 humanoid robot. That is not how manufacturing curves work. Medium-term impact. If Tesla successfully scales production into hundreds of thousands of units per year, component sourcing becomes far more influential. At high volume, actuator pricing drops dramatically. Electronics become standardized. Assembly processes become automated. Defect rates decline. This is when Chinese component leverage could significantly reduce cost. Instead of $200,000, the price might gradually compress toward $50,000 or lower. Not cheap, but no longer impossible. Long-term vision. Elon Musk's long-term goal of $20,000 to $30,000 per Optimus unit depends on three things. Massive production scale, continued actuator cost reduction, AI hardware cost compression. Chinese supply chains could accelerate point number 2. But Tesla will likely pursue partial vertical integration over time to avoid total dependency. This hybrid model keeps cost competitive while reducing geopolitical risk. The strategic conclusion. The real story is not made in China. The real story is cost curve mathematics. If Tesla wants Optimus to become mainstream, it must leverage global supply chains, drive component costs down, increase automation, balance geopolitical exposure. Cheaper components are a tool, not the final solution. The real breakthrough will not be where parts are made. It will be how fast Tesla can scale production safely and efficiently. Now I want to hear your perspective. Would you accept partial global sourcing if it made Optimus dramatically more affordable? Or do you believe full domestic production should be prioritized even at higher cost? Comment below and share your view. If you found this breakdown valuable, make sure you subscribe and turn on notifications so you do not miss our next deep dive into Tesla robotic strategy and AI scaling economics. And in our next video, we're going to analyze whether Optimus could eventually be bundled with Tesla vehicles and energy systems into one integrated ecosystem model. Thank you for watching. I will see you in the next one.